In the last lecture, we were able to implement a function get argument that will actually get us the options that we first over the terminal. Now, in this lecture, we are going to continue building our ARP spoofing detection tool. Now, we have successfully implemented the first step, which is to actually snip packet from the interface. And now we are going to move over to step number 2, which will actually check if there is an ARP spoof in place. And then we move over to step number 3, and which this will create an alert if there is an ARP spoof. And these are mapped to the functions that we are going to create: function 2, function 3, and function 4 according to our program plan. All right, so move over to our file where we start scripting the ARP spoofing detection tool. All right, so now we are going to create a function that will perform the snip packet from the interface. So we call it function snip packet. So actually we don't need to recreate it all over again, because we implemented this same function in packet snipping tool while we were creating packet snipping tool. So all I have to do, I would move over to the car Linux machine and then copy that packet snipping function and then come and paste it here. All right, so I am on the packet sniffer.py tool, which we created in our previous lectures. So all I have to do is to come over here, and then I'm going to copy the function snip packet. So I'll just copy it, then I'll come over to the Windows machine here where we are scripting the ARP spoof detection tool, and then I'm going to paste it here. Alright, so now we have our function snip packet that will actually snip packet from our interface. Only we have to make some modification here. We are not filtering the packet by 4080, we are filtering the packet by ARP protocol. So I'll just make a modification to this and then filter the packet by ARP protocol. Alright, so we have now successfully have the function snip packet that will actually snip the packet from the interface. Now the next thing that we are going to do, we need to implement the function analyze packet, which is a callback function that will get the packet that this function snip packet has obtained from the interface. So after the function snip packet has gotten a packet from the interface, it is going to transfer that, is going to call this callback function and then pass the packet to it. Now we can create a function analyze packet to perform analysis and further processing on this packet. So I'll just go down and then define function analyze packet. So I'll come here, defined analyze packet. And then now, and then I'm going to create as an argument when this callback on this function is being invoked, is going to be passed a packet as an argument. So when this snip packet call this callback function analyze packet, then it's going to transfer a packet to it, the 8 snip from our interface ARP packet, since we are filtered by ARP protocol. Okay, so now the next thing that we are going to do now, we are going to perform further check to make sure that the packet we are having is an ARP packet, and if it is an ARP packet, we want to make sure that it is an ARP response packet, because a ARP packet can be either an ARP request packet or an ARP response packet. But since we are dealing with ARP spoofing, we are dealing with ARP response packet. Remember how we were able to create an ARP spoofing tool? We created an ARP. We make use of ARP response packet. So I'm going to using if selection structure. I'm going to check if packet. Okay, then I'm going to check if it has a layer, if packet has layer called scapy.arp, scapy.arp. Now if it has this layer, and also now this will confirm it is an ARP packet, and at the same time, if this particular packet in its scapy.arp layer, in its scapy.arp layer, it in the OP field, then that OP field has the value of 2. Remember that if it has the value of 1, that means it is an ARP request. But if it has a value of 2, that means it is an ARP response packet. Now, if this condition is true now, that is when we are going to deal with the packet. And what we are going to deal with the packet, we are going to check the MAC address of the packet. Now we are going to through ARP protocol. Remember, in while we are creating the ARP spoofing tool, we created function getMAC to obtain a MAC address of a packet. So now we are going to also implement that same function now to get the MAC address of the packet using ARP protocol. So it is going to perform it's going to create an ARP broadcast packet, broadcast the packet to the whole of the subnet, and then get the MAC address of the IP address that packet is having. So making use of the FRSC field in the packet, that MAC address that value of the MAC address in the FRC field, we are going to make use of it to perform an ARP broadcast, get the MAC address that corresponds to that IP address, and then we are going to compare it now with the MAC address that this particular packet is having in its HWSRC layer. So basically what I'm saying is that we are going to have what we call an actual MAC. So an actual MAC, which is the actual MAC address of this packet. So, and to get the actual MAC, we are going to make use of function getMAC. Also, function getMAC, we don't need to create function getMAC from scratch. So all I have to do, I'll go over to the Kali machine, and then under our ARP spoof.py tool that we created, I'm going to copy this function getMAC. We have already implemented this. We have explained how this was created, so we don't need to go over it again. So I'll just go over here and then paste it under the function analyze packet. So I'll just come here 2 steps down and then paste my function getMAC. So the function of this the task of this function is to get the MAC address given an IP address as an argument. So we are going to obtain the actual MAC of this packet. So, and then we are going to obtain the IP address of this packet from the FRSC layer. So what I'm going to say, I'm going to invoke function getMAC, and then I'm going to pass to it a packet, and then under the, in that packet, skp.arp layer, and within that layer there's a field called FSRC. We have already seen this while we were creating our the ARP spoofing tool. So I'm passing to it. So basically what I'm passing to it the value of the FSRC, which is the source IP address of this packet. So wherever this packet is originating from, now the IP address of that packet, of that machine that is sending this ARP response packet. So and now using the FSRC, I obtain the IP address, and now I'm passing that IP address to function getMAC to get the MAC address. Now function getMAC will work, will perform its task, get the IP address, and then return the IP address, and then this will be assigned to variable actual MAC. All right. Now the next thing that I'm going to do, I'm now going to create another variable, and then I'm going to call it response MAC, or let me call it packet MAC. The MAC address now that the packet is bearing. The packet MAC equals to, and then I'm going to no, I'm not using getMAC again. I'm going to say packet, and then under the skp ARP layer, under the skp skp.arp layer, then within that ARP layer there is a field called HWSRC. Now this field bears the MAC address that packet is bearing. Now the MAC address that packet is bearing, does it correspond to what we're able to get using function getMAC? Down there, that is what we are going to perform a comparison to check if the actual MAC equals to the packet MAC. So since the packet MAC is telling us that it is MAC address, so we are going to check. Now if the two correspond, that means that we are not under ARP spoofing attack. So now we are going to go down and then check if actual MAC does not correspond. If it does not correspond, that means we are under ARP spoof attack. Then if actual MAC is not equals to packet mark. Now, if this condition becomes true, then we are going to print that we are under ARP spoof attack. So just print a message, print the alert that we are under ARP spoofing attack. So I will just print you are under ARP spoof attack. All right, so I'm going to save it. Now the next thing, we are going to go to the command prompt now, and then run this tool, and then go to the Kali machine, run the ARP spoofing attack, and then see whether this tool will tell us whether we are under ARP spoofing attack. So I'll just come down here, save this, then just go go to the command prompt first. So let me launch the command prompt. All right, now I will navigate to the directory where I have those files, cd desktop, then cd under desktop. There is a folder called lectures, so I'm going to navigate to that. Then I'll clear the screen, cls. All right, now I'll type Python, which is the Python interpreter. We only have one Python 3. It's only Python 3 that is installed on this Windows machine. That is why I don't need to attach 3. So Python, and now I will reference the name of the tool, ARP spoof, ARP. Okay, let me go and get the name proper. What is the name of the ARP spoof detector.py? So ARP spoof detector.py, ARP spoof detector.py, and then I'll just hit enter. All right, so our ARP spoofing tool is currently working, is running. Now I'll go to the Kali Linux machine and then launch the ARP spoofing attack. So let me zoom the terminal a little, then I'll clear the terminal, and then I'm going to navigate to that directory, cd desktop lectures, and then hit enter, clear the screen. Then I'm going to type sudo python 3, and then the name of the tool, ARP spoofer. Okay, ARP spoofer, ARP spoofer.py. Then the victim is 10.0, 10.0.2.15, which is the IP address of the Windows 10 machine, and then the gateway is 10.0.2.1, and then I'll just hit enter. Now I will enter sudo. Since I enter sudo, I have to enter my password, and then I'll hit enter. So let's wait until it says all right. So I mistyped the password. Let me retype it again. All right, as you can see, the ARP spoofing attack is in place now. It has started sending fake ARP response packet. Now let's go back to the Windows machine and see what is going to happen. All right, so we are having an error, index error. Let's index out of range. Okay, so so we have to go and see how we can handle this error. Okay, all right, embed this within a try statement, within try block. So I'll just type try, then try to do this. Okay, actual mark, then also push this so it will be within the try block, and then indent this. Now this is under try, is going to run this under try. Actual mark equals to get mark packet skp.arp, and then packet mark equals to packet the hwsrc layer of field of layer skp.arp of that particular packet, and then perform the comparison. Now if an error occurs, then we are going to accept the error. So I'm going to type here accept, accept, and then what are we accepting? The error. So okay, sorry, accept, and then the error that we are going to accept. Let's go back to the terminal and get the name of the error proper. Index error. So we are going to have index error, then we handle the error. So index accept, index, okay, so we have it here, index error. So if index error should occur, I'm telling the Python to now pass. Just continue running my tool. Forget about the error. So don't alert me that there's an error. Just forget about the error. Continue running the script, because some of the packet, not all the packet are ARP response packet. Some are ARP request packet. Okay. So if you have this error, forget about the error. Just continue running this tool. All right. So now let's go back to the terminal again, and then clear the screen. Okay, then rerun the ARP spoofing tool again and then see the result. All right. Okay, so as we can see, perfect. We have our tool is now working. It's telling us we are under ARP spoofing attack. You are under ARP spoofing attack. You are under ARP spoofing attack. You are under ARP spoofing attack. All right, perfect. So we have successfully implemented our ARP spoofing tool. Now, in the next lecture, we are going to see how we can make further improvement to it and how we can convert it into an executable Python script, so that we can run this particular tool on a system even if that computer does not have Python installed on it.